Hello, students! Hello, students! Welcome to BrainyBytes YouTube channel. I'm your AI mentor, Beck, and in today's video, we will study Mathematics Chapter 1, that is, integers. So, without any further delay, let's deep dive into an introduction video, Understanding Integers.
All right, let's talk about something you see literally everywhere, but maybe don't really think about. Negative numbers. You see them in weather reports, on your bank statement, even in an elevator going down to the basement. The rules can feel a little weird sometimes, but by the end of this, you're not just going to know the rules, you're going to understand why they work. So, let's dive in.
So let's just jump right into a real-world puzzle. You see a weather map like this, right? It says the temperature in Srinagar is -4 degrees. We see this all the time. But have you ever really stopped to think, what does that even mean? How can you have less than 0 of something?
That's the million-dollar question, isn't it? It feels kind of mind-bending. But I promise you, once you get the right tool for the job, it's actually incredibly straightforward. And we're going to build that toolkit right now, starting with the most important piece.
To get around in the world of integers, you absolutely need a map. And in the world of math, our map is the number line. Seriously, think of this thing as your own personal GPS for understanding how all numbers, positive and negative, relate to each other.
Okay, first things first, let's get our vocabulary straight. The word is integers. Don't let the fancy name fool you. It's just the official name for the whole gang. All the positive whole numbers you already know, all of their negative opposites, and good old 0, sitting right there in the middle. If a number's bigger than 0, it's positive. If it's smaller than 0, well, it's negative. That's it.
And here is our map in all its glory, the number line. Think of 0 as your home base, it's ground level. When you move to the right, the numbers get bigger, they get more positive. That's like the temperature getting warmer or going up floors in a building. And if you move to the left of 0, the numbers get smaller, more negative, like it's getting colder outside or you're heading down into the basement.
Okay, so we've got our map. Now what? Well, now we start moving around on it. Adding and subtracting integers is really just a game of taking steps to the left or to the right on this line. Let's see how it works.
This first part is stuff you already know. It's basically just walking. If you start at position 3 and you add 2, you just take 2 steps to the right, and bam, you land on 5. If you subtract 2, you take 2 steps to the left, and you land on 1. Easy enough, right? But here's where the fun begins. What happens when you start subtracting negatives?
Whoa. Okay, this quote looks super technical, I know, but it holds the secret code. Let's break it down. Additive inverse. That is just a super fancy way of saying the opposite number. So, the opposite of 5 is -5. The opposite of -10 is +10. That's all it means. And knowing that one little thing unlocks everything.
So here it is, the big reveal. Subtracting a negative number is the exact same thing as adding a positive. Think about it in terms of money. If I tell you that I'm going to take away an $8 debt that you have, what just happened? You're actually $8 richer, right? You just gained money. That's why subtracting a negative number on our number line actually moves you to the right, toward the bigger, more positive numbers.
Now, let's switch gears and talk about multiplication. If addition is like taking small steps, you can think of multiplication as taking giant leaps. And guess what? We can keep using that same idea of debts and gains to figure it all out.
Okay, multiplying a positive by a negative, it's pretty intuitive. If you take on a $5 debt and you do that 4 separate times, well, you now have a total debt of $20. Your net worth has gone down by 20. It's like taking 4 big leaps of 5 spaces each to the left. But what about a negative times a negative?
This is where things get really cool. Instead of me just telling you the rule, let's uncover it together by looking for a pattern. Let's start with -3 times 2. That's -6. Simple enough. But watch what happens as we go down. -3 times 1 is -3. The answer just went up by 3. Let's do it again. -3 times 0 is 0. Whoa, it went up by 3 again. You see the pattern here?
So if we just follow that exact same logic one more step, every single time the number we're multiplying by goes down by 1 and the answer goes up by 3. So what has to happen next? What's the next number in our sequence? Exactly. It has to be +3. It's the only answer that keeps the pattern going. This little exercise shows us that a negative times a negative is a positive, not just because a teacher told you so, but because it's the only answer that logically makes any sense. All right, let's quickly cover some of these official properties of integers. And again, do not let the fancy names scare you off. These are just common sense shortcuts that make life easier. You probably use these ideas all the time, and you don't even realize it.
First up, we have the commutative property. All this means is that when you're adding or multiplying, the order just doesn't matter. 7 plus -3 gives you the exact same answer as -3 plus 7. It's like the shopping cart analogy here. It doesn't matter if you put the milk in first or the eggs in first, you have the same stuff at the checkout. Next, we've got the associative property. This one is all about grouping. If you're adding a big, long string of numbers, it doesn't matter which pair of numbers you decide to add together first. The final answer is going to be the same no matter what. You can group them however you want to make the math easier on your brain.
And last but not least, the distributive law. Now this one looks a little more complicated, but really it's just about giving you options. You have two ways to tackle the same problem. You can either solve what's inside the brackets first, then multiply, or you can distribute that outside number to each number inside the brackets and then add those results up. Look at that. Both paths lead to the exact same answer, 12. Pretty neat, huh?
Okay, deep breath. We've got our map, we know the moves, we've learned the shortcuts. Theory time is over. Now it's time to put it all together and see how this actually works in the real world. Let's solve a problem.
This problem is a perfect real-world test, so let's break it down. First, we figure out all the positive points from the correct answers. That's 7 times 5, which gives us 35. Great. Now let's calculate the penalty points from the wrong answers. That's 5 times -2, which is -10. And for the final step, we just combine our positive and negative scores. 35 plus -10 gives us a final score of 25. See how every single rule we just learned clicks perfectly into place.
And here's the thing. This isn't just about quiz scores. You can use this exact same logic for everything. Calculating profit and loss in a business, tracking your bank account with all its deposits and withdrawals, or even figuring out the final depth of an elevator that starts above ground and travels way down into a mine. The principles are totally universal.
So, if there's one thing you take away from all this, it's that integers aren't just some abstract math concept. They're a language for describing all the ups and downs of the real world, from the temperature outside to the money in your pocket. We've gone through the basic rules and, more importantly, why they work. So the real question for you is, now that you can see both sides of zero, what part of your world can you understand just a little bit better?
Well, thanks, Sam, for the complete overview of the chapter. Now, let's revise the concepts one by one in detail. First, let's talk about the integer universe. Here is a concept map that illustrates the collection of integers. Integers include the whole numbers, that is, the 0 and the positive numbers, along with the negative numbers, as shown in the blue shell. But before moving forward, we must also know about the absolute value of any integer. Yes, the absolute value, or the mod of a, is defined as the pure numerical value of an integer, regardless of its sign. It is the measurement of the physical distance from 0, making it always non-negative. For example, if a equals 4, or a equals -4, the modulus of a is going to be +4. That is, always non-negative. Now, let's talk about number line, which says direction determines value. You might have heard about number line in lower classes. It tells us that as we move from left to right, the value of number increases. Right versus left. An integer is greater than all integers to its left and less than all integers to its right. Let's take three numbers, 0, 1, and 2. The digit 2 is always greater than 1, while 0 is always less than 1. Positive versus negative. By physical placement, every positive integer is greater than every negative integer. It means that 2 is always greater than -1, or any number to the right of 0 is always greater than to a number present on the left of 0. No limits. It means that the line extends infinitely. There's no largest or smallest integer. Addition is combining distances on the axis. Okay, let's imagine a guy standing at 0 facing towards right. If he walks forward by +4 and then +2, he walks a total of +6. This means that two positives add as natural numbers and gives a positive sum. On the other hand, if the guy walks backward or towards the left of 0, then we ignore signs, find the sum, and attach a negative sign. It means that two negatives always add up to a negative integer. In the case of two opposite signs, we subtract smaller absolute value from the larger absolute value and take the sign of the larger value. You see, in tug of war, the larger arrow always wins, dictating the sign. So remember, two positives adds to a positive, two negatives adds to a negative, whereas a positive and a negative adds to a positive or a negative with sign depending on the larger value. Now, let's take a look over the immutable properties of the integer addition. First, the closure property. It says that if a and b are two integers, then their sum, a plus b, is always an integer. It's very simple to understand. Second, the commutative property, which tells us that two integers, no matter in which order of sequence they are added, results always equal. Next we have is the associative property, which states the grouping of integers do not affect the result. You can substitute the values of a, b, and c as any positive or negative value. You will definitely get equal results. Now, let's understand the properties of additive identity and additive inverse. The additive identity, it tells us that any integer added to 0 results in integer itself. For example, if you add -3 to 0, you get -3 as the answer. The additive inverse, it says that for every a, there is a negative a, such that a plus negative of a is equal to 0. So if you are asked to tell the additive inverse of 7, the answer is -7, whereas the additive inverse of -7 is 7. All these above discussed properties are very helpful in solving trivial calculations, so learn them by heart. Did you know that subtraction is an illusion? Let me tell you how. It is the mirror flip diagram, which tells us that subtracting an integer is the exact same action as adding its additive inverse. It means that if I subtract an integer b from a, or I directly add the additive inverse of b to a, both of these operations will give us same result. Now, there are some limitations to this matrix. Only the closure property is true for subtraction, which tells us that the difference between two integers is always an integer, whereas subtraction is neither commutative nor associative. It means that swapping the order breaks the equation. You can clearly understand it with an example. Not only this, even regrouping of integers changes result. So next time, be sure that only the closure property is valid for subtraction. With this, now let's talk about the multiplication rules, scaling and sign flipping. Yes, multiplication of two integers with different signs equal to a negative integer, while on the other hand, multiplying two integers with same sign results in a positive integer. You can simply remember it by learning that hanging out with a negative integer makes you negative. Well, now let's look at the ultimate eraser, which says that any integer multiplied by 0 collapses to 0. For example, if I multiply an 8 or a -8 by 0, it will definitely result to 0. Now, if you have made up to so far, let's discuss about the inherent symmetry of multiplication properties. First, the closure property. It says that the product of any two integers, a cross b, is securely contained within the integer universe. That is, the result of a cross b is also an integer. Second, the commutative property, which strictly states that order does not affect the product. Here, you can understand it with an example. No matter which integer you multiply first, you end up getting the same result. Next we have is the associative property, which states grouping multiple factors does not change the outcome. You see, how this grouping works, it's really effective in carrying out typical calculations. Last but not the least is the multiplicative identity. It tells us that multiplying any integer with by 1 gives you the integer itself. You can look at these examples to verify this equation. But wait a minute. Have you noticed why these identities are separated from the properties? Is there any difference between both of them? The answer is yes. An identity is an equation that is always true for a given variable, whereas a property is a universal rule that facilitates easier problem solving by allowing rearrangement or regrouping of numbers without changing the final result. If you find this fact amazing, then do not forget to hit the like button. The calculation cheat codes. Now we'll talk about the most important property of distribution and the sign parity dial. First, the distributive engine. The distributive law makes calculations significantly easier by distributing multiplication over addition or subtraction. You shall understand it in more detail in the next slide, so chill. But before moving ahead, let me tell you about the sign parity dial, which is just a short trick to find out the resulting sign of the answer by counting the number of negative factors in the question. It means that odd number of negative factors yield a negative, whereas even negative factors yield a positive. Yippee! The distribution bridge. This slide explains the distribution law in more detail. Here, you see at the expansion of the property, which directly shows us how the integer a is distributed in both b and c, separated by a positive or a negative sign depending on the given term inside the bracket. You can also take a look over the visual proof of this property, which will help you understand it better. The ultimate prime. It's division time. Now let's talk about the inverse mapping along with the sign rules. This is the perfect example to show how division actually works. But when we talk about the sign strategy, it's identical to sign rules used in multiplication. That is, if two integers with same sign are divided, the sign cancels out and results in a positive integer. While on the other hand, if we divide two integers with different signs, the resulting integer is always negative. Not only this, the inverse operation comes with limits too. Rule number 1, dividing two integers does not guarantee an integer result. For example, 12 divided by 5 gives 2.4, which is a real number and not an integer. Rule number 2, division is non-commutative. Order strictly matters as shown in the given example here. 12 divided -3 is non-equal to -3 divided 12. So do make sure how you write while working with division operation. Now, it's time to understand the hierarchy of enclosures, that is, order of solving brackets according to their precedence. The rule states that we must always solve from the innermost layer to outermost one. The vinculum, or the line bracket, has the highest precedence, while the rectangular brackets have the lowest. Always remember to solve from highest precedence bracket to lowest precedence one. So, whenever you see a bunch of brackets in a question, you have the key of hierarchy to unlock these enclosures. Whoa! The master algorithm, BODMAS. The BODMAS rule. BODMAS is an acronym used in mathematics to define the order of operations for solving complex expressions, ensuring they are solved in the correct sequence. It stands for brackets, order, powers or roots, division, multiplication, addition, and subtraction. We had studied about the brackets in the previous slide. Now let's take a look over solving other operations using this funnel filter diagram. You see? The operations are lined according to their precedence. The operations such as division and multiplication have equal rank, and they are always solved from left to right, no matter which of them appears first. So do make a note of this. Exactly the same concept is applied to the addition and subtraction operations. You can understand it more clearly with an example shown in this slide. You see? How we apply filters one by one to this question. Isn't it amazing? Perhaps whenever you see a question of such type, with multiple operations or brackets, always use the BODMAS rule. Well, now it's time to understand the physics of integers. These are some common examples of space and climate usually asked in exams. First, the mineshaft, elevation. The descent rate of the shaft is 4 meters per minute. Where is it after 1 hour? An easy-peasy question, right? Let's break it down to simple steps. We know that the shaft is descending down below the ground level, that is, in a negative direction. Therefore, the rate of descent becomes -4 per minute. Since an hour has 60 minutes, and we are given with descent in 1 minute, that is -4 meters, total descent on 60 minutes becomes equal to -4 times 60 minutes, which results in -240 meters, or 240 meters below ground level. Now, let's jump on to another case of thermometer. Here, we are given with the temperature at noon, which is 10 degrees Celsius, and it drops by 2 degrees Celsius per hour until midnight, which is a time span of 12 hours. From this detail, we can find the total decrease in temperature and finally add it to the original temperature to get the final result. So whenever you are asked to find the final temperature, make sure that you add the decrease or the increase in temperature with sign to the initial temperature. With same concepts in mind, let us jump on to the next slide. Here we have the mechanics of integers. Now let's calculate some scores and finances. The competitive scoring. You might have your elder siblings or seniors talking about their competitive scoring, a +4 or -4. Similar to that, here we are given with an exam rule, which says +5 marks for correct and a -2 for the incorrect answer. Here, a boy Rohan scored -12 total, but had 4 correct answers. We have to find how many were incorrect. Again, it is simple formula-based. We know that the sum of the correct answers and the incorrect answers gives us the total score. Since we have to find only the incorrect ones, we must subtract the correct score from the total score. And here it is. Points from correct ones equals to +20. Now, to calculate the points from the incorrect ones, we must directly subtract the correct score from the total score as mentioned earlier. It finally gives us -32. Although one incorrect answer costs me -2 marks, then how many wrong answers am I supposed to give in order to get a total of -32 marks? And the answer to this is +16. You can apply inverse mapping, as shown, to get the same result. Now, let's take a look on the profit and loss scheme. The rule says that profit is always taken as positive, while loss as a negative quantity. Combining both positive revenues and negative costs fundamentally relies on the precise execution of addition and subtraction. So, remember profit as positive and loss as negative. Voila! We finally made it to the end of this journey of understanding integers. I hope I was able to polish your concepts to the next level. This is your AI mentor, Noah, and I will see you in the next video. Till then, subscribe to BrainyBytes YouTube channel to get notified as quick as a bullet.